Hi, today we're going to be looking at the operators lab and let's get started. So, the first thing it says is you decide to build a shed and want to know you want to know beforehand the area of your yard that it will take up. Create two constants, width and height, with value of 10 and 20 respectively. Create an area constant that is the result of multiplying two previous constants together and print out the results. Okay, let's do this. So we declare a constant by the let keyword, and it's telling us the first constant, the name is going to be called width, and it has a value of 10, and the second is height, and that has a value of 20. And lastly, we're going to create a constant that is called area, and this will be the result of the multiplication of width times, and we use the asterisk to imply multiplication arithmetic, with the height. Okay, and lastly it says print the result. So we're going to go ahead and print area. Okay, and the area should be printed here and it should say 200. Great. You decide that you'll divide your shed into two rooms. You want to know if dividing it equally will leave enough room for some of your larger storage items. Create a room area constant that is the result of dividing area in half. Print out the results. Okay, so let's have a look. So what we have to do here is we're going to have to create this constant called room area, and room area is going to equal area divided by 2. Okay, and we're going to print out room area. Cool. All right, and that should give us a result of 100 because 200 divided by 100 is 100. So create a perimeter constant whose value equals width plus height, then print out the result. Okay, let's go ahead and do that. So same thing, let, and perimeter is the name of this constant, and it equals width plus height plus height. Great. And we're going to print out the constant perimeter. Great. Okay. So here it says print what you would expect the result of integer division of 10 divided by 3 to be. Create a constant integer division result that is the result of 10 divided by 3 and print out the value. Okay, let's see what this looks like. So, what do I think the result will be of an integer division 10 divided by 3? So I'm going to say I think the result would be 3. Okay, so that's what I think the result will be. Let's actually check it out. So it says here, create a constant called integer division result. So it's a mouthful, integer division result. And let that be equal to 10 divided by 3. And then print the value. So print integer division result. And we should get 3. Okay. Now create two constants, double 10 and double 3, set to 10 and 3, so the values of double 10 is 10 and the value of double 3 is 3, and declare their types as double values. Declare a final constant, division result, equal to the result of double 10 divided by double 3. Print the value of division result. How does this differ from the value when using integer division? Okay, great, let's do that. So we're going to create two constants. The first is called double 10, and we're going to declare this as a double type, and we're going to give it a value of 10. We're going to declare a double 3, and we're going to say that this is a double type, and we're going to set it to equal 3, give the value of 3 rather, and we're going to create division result, and that's going to equal to double 10 divided by double 3. And finally, we're going to print out the division result. Okay, that should give us 3.33333. Great. So lastly, it says, how does this differ from the value of the division? Okay, so I'm gonna go ahead and print my statement here, how I think it differs. This differ, differs in that it gives you the exact result with a decimal, whereas integer division gives you only the whole number and ignores the remainder or decimal. Great. Okay. So that's we're almost done the first page. Okay, given a value of pi, 3.1415927, create a radius constant with a value of 5.0. Then calculate the diameter and circumference of the circle using the following equations and print the results. Okay, so we've got some equations here that this lab gives us. Diameter equals 2 times radius and circumference is 2 times pi times radius. So they've given us that pi equals this. So what do we have to do here? Well, the first thing it tells us is create this constant called radius and set it to equal to 5.0, and then create this thing called diameter, right? So this constant called diameter, and we're gonna initialize diameter to equal to 2 times radius, right? And we're gonna create circumference here. That's a hard word to spell. And circumference obviously equals 2 times pi times radius. Beautiful. Okay. Lastly, we're gonna print diameter, and then we're gonna print circumference. Great. So it should give us the circumference and the diameter here. So the diameter is 10.0 and the circumference is 31.4. Great. Pretty cool stuff. Okay, moving on to the next page. So let's have a look here. It says your fitness tracker keeps track of users' heart rate, but you might also want to display their average heart rate over the last hour. Create 3 constants: heart rate 1, heart rate 2, heart rate 3. Give each constant a different value between 60 and 100. Create a constant added HR equal to the sum of all 3 heart rates. Now create a constant called average HR that equals added HR divided by 3 to get the average. Print the results. So that's a mouthful. If you follow it slowly, you should end up doing what I'm doing here. So the first is let heart rate 1 equals 72, and let heart rate 2 equal 65, and let heart rate 3 heart rate 3 equal, I'm gonna give it a value of 80. Obviously this is a mistake, we gotta do this, and I missed the T. Great. So we've declared heart rate 1, heart rate 2, heart rate 3. We've given it a value of values of 60 to 100. And now it says create this thing called added HR, and it's telling us to give it a value that is the sum of heart rate 1 and heart rate 2 and heart rate 3. Great. And then it told us to create this other constant called average heart rate, and average heart rate has to equal to the added, sorry, I totally missed that, the added heart rate divided by 3, and finally we print average heart rate. And if we print it, we should get an average of 72. 72 plus 65 plus 80 should give us an average of 72. Cool. All right, now create three more constants: heart rate, heart rate 1D, heart rate 2D, heart rate 3D, equal to the same values as heart rate 1, 2, and 3. These new constants should be of type double. Create a constant added HRD equal to the sum. So essentially, it's telling us to do the same thing all over again, except declare these as doubles and not singles. So let's do this real quick. Heart rate 1D, and we're going to declare this as a double, and we're going to give it the same value. Going to do the same thing here. Heart rate 2D, double, and we're going to give it a value of 65. Let heart rate 3D, a double, and we're going to give it the same value of 80. And let added heart rate D, and by the way, the D here stands for double, so it's just proper naming conventions, just to make it easier for us to understand what we're doing here. Oops, 2D plus heart rate 3D. Great. And finally, let average HRD, which is heart rate D, equal to added HRD divided by 3, and we're going to print average HRD, and that should give us 72.3333. So what did we do here? In this case right here, we've created three constants, and since we didn't explicitly tell Playgrounds what type of constant this is, what type it is, it automatically assumed it is a integer. So if I go ahead and click on option and click on the name, it should say int. So when we added all three of them here and divided them by 3, we got the average, and we printed it, we got a value of 72 right here, right? However, if we did the same exact thing with double, which holds a floating point number that is a decimal number, and we did the same thing, added all three numbers and divided them by 3, we got 72.3333. This is another illustration of how integer division does not give you the remainder. Okay, great. So let's move on. Imagine that partway through the day, a user has taken 3,467 steps out of the 10,000 steps. Create a constant called steps. Okay, let's do that. Create a constant called steps, and goal both will need to be of type double so that you can perform accurate calculations. Steps should be assigned the value of 3,467, and goal should be assigned 10,000. Create a constant percent of goal that equals an expression that evaluates to the percent of the goal that has been achieved so far. So pretty easy stuff. So let's create this constant called steps, and we're gonna say we're gonna explicitly tell Swift to make it a double, and we're gonna give the value of 3,467. We're gonna create a new constant called goal, and we're gonna explicitly say make this a double. We're gonna give it a value of 10,000. Then we're going to create a constant called percent of goal, and we should probably make that a double as well. And we're going to say it's steps divided by steps divided by goal times 100, because we want the percentage. So I'll explain why I did that. So steps should be assigned the value of 3,400, and goal should be assigned 10,000. Great. Create a constant percent of goal, so we did that. That equals an expression that evaluates to the percent of the goal. Well, how do you find percentages? We divide and multiply by 100, because percent just literally means out of 100. So to find a percent, you divide the numerator by the denominator times 100, and you get the percent. So that's why I did that. And finally, we're going to print percent of goal, even though it actually doesn't say to print it, but I'm going to print it either way. So if we do that, we should get a value of, oh, it's giving me an error here. Consecutive statements on line must be separated by a semicolon. So that's because I put a space in there, my fault. Okay, it should work now, and it gives us a value of 34.67. That is the percent that is completed. 3,467 steps out of 10,000 is 34.67%. Okay, great. Moving on to the third page. Okay, declare a variable whose value begins at 10. Using addition, update the value to 15 using the compound assignment operator. Using multiplication, update the value to 30 using compound assignment. Print out the variable value after each assignment. Okay, great. Let's do this. So variable, we declare variables by the keyword var, and the variable is called start, and we're going to give it a value of 10, just like the instruction tells us, and we're going to say print start. Oh, sorry, start. Great. So we've printed this variable called start, and now we're going to update it by adding 5 to it. So start, we could do start equals start plus 5, and that will give us a value of 15 in a second. We have an error here, consecutive statements, okay. Again, put a space in here, so we don't need this anymore. Let me just go ahead and get rid of that. So it gives us a value of 15, but there's actually a shorter and faster way of doing this. And instead of saying start equals start plus 5, what we could do is we could say start plus equal 5. So if we do start plus equal 5, it gives us the same value of 15. So essentially what we're doing here is we're saying, listen, take whatever start is, add start to itself, and add another 5. That's what that means. If we print start, we should get a value of 15 here at the bottom in a second. Great. And now it says using multiplication, update the value to 30 using compound assignment. Okay, great. So we go start. I'm gonna put space here just to separate it. Start. Again, multiplication equals, right? Multiplication equals 2. And that should give us a value of 30. If we print start now, that should give us a value of 30. Great. So let's move on here. Create a variable called piggy bank and begin at 0. You will use this to keep track of money you earn and spend. For each point below, use the right compound assignment operator to update the balance in your piggy bank. So we're gonna go, your neighbor gives you $10 for mowing her lawn, you earn $20 more throughout the week doing odd jobs, you spend half your money on dinner and a movie, you triple what's left in your piggy bank account by washing windows, you spend $3 at a convenience store, print the balance of your piggy bank after each step. Okay, let's do this. So at first we're gonna create this variable called piggy bank, and we're gonna initialize it at 0, give it a value of 0. Then we're gonna print piggy bank, and obviously the value should read 0, and it does. Great. Moving on, we're gonna say piggy bank plus equals 10. Why? Because our neighbor gave us $10. That's fantastic. We go ahead and print piggy bank now, and it should say 10 at the bottom here. Give it a second. There we go, 10. Now moving on to the next line, we're going to go ahead and say piggy bank. What does it say here? You earn $20 more. So we're going to add another $20 to it. So plus equals 20. And we're going to go ahead and print piggy, well, that's wrong, piggy bank. And that should give us a value of 30. Yeah, 10 plus 20 is 30. Okay, Next here, we're gonna spend half of our money on a dinner movie. We're gonna go piggy bank divided by, oh, sorry, divided equals to 2. So essentially we're dividing it by 2, and then we're gonna print piggy bank, and that should give us a value of 15. 30 divided by 2 is 15. And then you triple what's left in your piggy bank by washing windows. Great, so piggy bank triple is another way of multiplying. So multiplication equals, so asterisk equal 3, and if we print this, we should get a value of 45. 15 times 3 is 45. And lastly, you spend $3 at a convenience store. So we go piggy bank minus equals 3, and we print the value of piggy bank, and that should give us a answer of 42. 45 minus 3 is 42. Great, let's move on. Fourth page here. So it says the most basic feature of your fitness tracking app is counting steps. Create a variable steps and set it equal to 0. Then increment it by 1 to simulate a user taking a step. Okay, well that's pretty easy. How do we do that? var to create a variable. The variable is called steps. We give it a value of 0 to begin with. Great. Then we increment it by saying steps plus equals 1, and now it has a value of 1. Great. In addition to tracking steps, your fitness tracking app tracks distance traveled. Create a variable called distance of type double and set it equal to 50. This will represent the user having traveled 50 feet. You decide, however, to display the distance in meters. 1 meter is approximately equal to 3 feet. Use a compound assignment operator to convert distance to meters. Print the results. Okay, that's pretty easy stuff, so let's do that. So we're going to create a variable called distance, and we're going to say it's of type double. We're going to give it a value of 50. That's great. Now, since this is in feet and we want it to be in meters, and approximately every 3 feet equal a meter, so we're going to divide this by 3. So how do we do that? So we go distance divide equal 3, and that should be it. Now if we go ahead and print the value of distance, it should be a third of 50, and a third of 50 should be 16.66666. So that's that. Okay, moving on to the next page. The next page says print out what you think 10 plus 2 times 5 evaluates to. Then print out the actual expression. Okay, so let's have a look. So I'm going to print what I think it should equal to. Well, I know orders of operations, and I know this might be tricky for some, but you don't actually add first, you have to multiply first. So 2 times 5 is 10, plus 10 equals 20. Most people might do, so the answer should be 20. Most people will do 10 plus 2, which is 12, times 5, that gives you a 60. So I'm going to say I think the answer should be 20. Okay, let's see if I'm right. Let's go ahead and print the actual statement, 10 plus 2 times 5. And let's see what it says here. Great, so I think the answer should be 20, and in our next statement, the answer is actually 20. Great. In a separate print statement, add the necessary parentheses so that addition takes place before multiplication. Okay, so if I wanted to make the addition first and not multiplication, right? So if you know order of operations, obviously parentheses or brackets, if you'd like to say use that word, always comes first. So to do that, it's very simple. All you have to do is write the same statement. However, this time you're going to add 2 extra brackets that actually do the following to give precedent to the addition, which is 10 plus 2. And if we print this, this should say 60. Great, because 10 plus 2 is being evaluated first, and that's 12, and 12 times 5 is 60. Okay, great. Print out what you think 4 times 9 minus 6 divided by 2 evaluates to. then print out the actual result. Well, if I do the math real quick in my head, I should get 33. So I think the result should be 33. And let's actually go ahead and print it out and do it, and you'll see why in a sec. So 4 times 9 minus 6 divided by 2 equals, and the result here, the result should, just give it a sec, let it update, the result should be 33. And why is that? Well, if you do orders of operation from left to right, you'll see that you do 4 times 9. Well, what's 4 times 9? 4 times 9 is 36. Then you don't do subtraction because there's a division, and division takes precedent before subtraction. So remember, this is 36, and 6 divided by 2 is 3. So really it's 36 minus 3. Well, 36 minus 3 is 33. Great. In a separate print statement, add in the necessary parentheses so that the subtraction is prioritized over the multiplication and division. Okay, so we pretty much do the same thing here. 4 times 9 minus 6 divided by 2. However, if we wanted to give precedence to the subtraction, we add parentheses right here. And now the subtraction will come in first. So 9 minus 6 is 2. And then 4 times 2 is 8. 8 divided by 2 is 4. Oh, hold on. Sorry, I did the math wrong. 9 minus 6 is 3. 3 times 4 is 12. 12 divided by 2 is 6. And it gave us 6. Great. Let's move on to the next page. Okay. So the next page says, if you completed the fitness calculations exercise, you calculated an average heart rate to display to the user. However, using proper order of operations, you can do this in few steps. Create 3 separate heart rate constants, all of type double, with values between 60 and 100. Then create a constant equal to the average heart rate. If you use correct order of operations, you can do the heart rate calculation in one line. So let's do this. So what are we doing here? We're creating 3 constants. The first is called heart rate 1, and we're going to give it we're going to explicitly say it's a double, and we're going to give it a value of anywhere 60 to 65. 60 to 100. My fault. Second is heart rate 2, and it's explicitly a double. And we're going to give it a value of, say, 75. And lastly, we're going to go heart rate 3. Now we're going to lowercase this because of naming conventions and camel casing. We're going to say this is a double, and we're going to give it a heart rate of 89. And lastly, we're going to set let average heart rate. No, I'm just going to go HR here. Nice and simple. And again, so here we could do this actually in one line. So what we do is we prioritize the addition part. So previously we did this in 2 lines in the beginning of the lab. So we're going to go heart rate 1 plus heart rate 2 plus heart rate 3. Okay, and then we're going to divide all of this by 3. We should get a answer here. It's giving us an error here. Let's have a look of why that is. Use of unresolved identifier heart rate. Yes. Okay, so the error is because their heart rate does not exist. It's heart rate 3. So I totally forgot that. Once we put that in, it fixes it, and it should give us an answer here. And oh, it doesn't give us an answer because I didn't print anything. The answer is right here, 76.3. But if I print average heart rate, it should give me the result right here at the bottom, 76.3333. Okay, great. One feature you might want to give users is to display their current body temperature. Create a constant temp in Fahrenheit equal to 98.6. You may want to also show the temperature in Celsius. You can convert Fahrenheit to Celsius by taking temperature in Fahrenheit and subtracting 32, then multiplying the result by 5.0 divided by 9.0. Create a constant, temp in Celsius, that calculates in one line the temperature in Celsius. Okay, so how do we do this? Well, let's take this one step at a time. First, we're going to create this constant called temp in Fahrenheit. It's a tricky word to spell. And we're going to give it a value of 98.6. Great. And then we're going to create this constant called temp in Celsius. And we're going to give it a value of temp in Fahrenheit, right? Because it's telling us the formula. So take temp in Fahrenheit and subtract 32. And multiply by 5.0 divided by 9.0. Okay, great. Gonna add another bracket here and another bracket here to complete the statement. Okay, let's go ahead and see the result here. And we've made an error, a small error, and the error simply being is I added this bracket here. This should fix it. Sorry, the error is actually this right here. You got to put a space between the operator and the number. Great, that fixes it, and the answer is 76.33333. Okay, sorry, the answer is 37. I didn't print anything. So if I go ahead and print, and I say temp in Celsius, it should print out 37. Give it a second. And it's giving me an error. Because it's an uppercase P, not a lowercase p. Great. See? Swift is case sensitive, so you have to be careful with your uppercases and your lowercases. Great. So this is very live, and you'll see the mistakes that I'm making. Okay, so let's look at the 7th page here. Let's look at the instruction. Create an integer constant x with a value of 10 and a double constant y with a value of 3.2. Create a constant multiplied as integer equal to x times y. Does this compile? If not, fix it by converting your double to an int in a mathematical expression. In the mathematical expression, print the result. Okay, so let's have a look. So we create this constant called x. We declare it specifically as an int, and we give it a value of 10. We create a constant of y. We explicitly declare it as a double. We give it a value of 3.2. Then we create this constant called multiplied as integers, and we multiply x times y. And here it should give us an error, and the error should say, listen, you can't pretty much do that because you can't multiply an int with a double. So how do we fix that? Well, we could fix it by changing this to a double or changing this to an int and giving it a value of 3 instead of 3.2. But it says here, can fix this by converting double to an int in the mathematical expression. So the y value is the double. We're going to convert it to an int. We convert it to an int by using the keyword int and surrounding the constant y with parentheses. And then lastly, it says print multiplied as integer, so we see what the answer is. And the answer should read out 30. Well, why is that? Well, when we converted y to an int, 3.2 changed to 3, and 3 times 10 is 30. So that's why it came up to 30. Now here it says, create a constant called multiplied as double equal to x and y, but this time convert the int to a double in the expression. Print the result. Okay, so let's see what that looks like. So we're going to go ahead and create this constant called multiplied as doubles, and we're going to set it to equal to x, right, times y. Okay, cool. Now, is this going to work? No, it's going to give us the same exact error as before. Just give it a second. It's going to give us the same error and saying, listen, you can't actually multiply an int with a double. Okay, great. Except this time, what we're going to do is we're going to change the x to a double. So we're going to do that. And this is how we change the x, which is an int over here. We're going to change it to a double. And now we no longer have an error. And we're going to go ahead and print multiplied as doubles, and that should give us an answer of 32. Just give it a sec here. It's running, and it gives us an answer of 32.0. Perfect. Lastly, are the values of multiplied as integers and multiplied as doubles different? Print a statement to the console explaining why they are different. Well, I've already explained this, but I'm going to do it again. Essentially, when multiplying as integers, we ignore the decimal, thus resulting in an answer of 30 as opposed to 32 when using decimals. That's essentially the short of it. There we go. Perfect. Okay, let's move on to the very last page here. If you completed your the fitness calculation exercise, you calculated the percent of the daily step goal that a user has achieved. However, you did this by having steps be a type double, but you can't really track a partial step. So steps should probably be of type int. Go ahead and declare steps as int and give it a value of a value between 500 and 6,000. Then declare goal as type int and set it equal to 10,000. So let's have a look here. So this is pretty easy stuff. So we create a constant called steps, and it's of type int, and it's equal to 3,940, let's go 49, okay? And we're gonna go let steps, let goal equal to, well, it's an int type and it's equal to 10,000. Great. Okay. Now create a constant percent of goal of type double that equals the percent of the goal that has been reached so far. You'll need to convert your constants of type int to type double in your calculation. Okay, how do you do that? So we create percent of goal, which is a constant, and we say, listen, this needs to be a double type, and we're gonna divide steps by goal to get a percent, except we need to convert them to a double. So we're going to go ahead and say double steps. So we're converting steps into doubles right here in the equation, the mathematical equation, and we're converting goals into double as well. And we're multiplying this by 100 because we want to find the percent. And if I go ahead and print percent of goal, that should give me the percentage, 39.49, which makes sense because 3,949 steps out of 10,000 is 39.49%. Okay, perfect. Thanks for watching.